Hey everybody, it's Will from PC World here. I'm here with Dr. Ian Cutress, Tech Potato. Welcome back.
Thank you for having me.
It's good to have you, sir. I have a question for you. He knows what the question is, but I'm going to say it for you. NVIDIA right now is rumored to be releasing a new GPU next year based on Blackwell, which is the thing that they've been selling to AI customers for the last little bit. And I heard a rumor that those chips are really, really expensive when they sell them to like OpenAI, for example, to the tune of $20, $30, $40, $50, maybe even $60,000.
Or
more. So my question for you is, why would NVIDIA ever sell me, say, RTX 5090 for $1,500, $2,000 when they could sell it to OpenAI for 50 grand?
So this is not an NVIDIA specific issue.
Okay.
AMD also sells lots of AI chips. So why would they ever sell a consumer card? And the gaming market itself is going through a bit of up and down right now. If we look at the latest quarterly financials, NVIDIA actually made more money in gaming last quarter than it did. AMD went down.
But how much money in gaming compared to AI?
Yeah, so I think it was somewhere around $3.5 billion compared to 36.
Yeah,
so there's a 10x factor.
Yeah.
And it comes down to some of the technologies that the AI chips need. So typically when you buy a chip, you may think of it as just one piece of silicon on your board, and we've got plenty of GPUs behind us, and then some memory around it. And there's a supply chain to deal with all of that. And if you're getting a cheaper chip, you may use some simple packaging. If you're getting a more advanced high-end chip, you may have advanced packaging, just to enable that memory bandwidth and connectivity and everything else that goes in. With the AI machine learning chips, you have one or two big compute dies and then multiple HBMs around the side.
HBMs?
So high bandwidth memory.
Okay.
So the main three suppliers for that are SK Hynix, Micron, and Samsung. Which ones are validated depends what you're breeding in. Is
that like a GDDR6 or is that something different beyond that?
So it's beyond that. It's a multiple bandwidth of GDDR,
okay.
But the way you package it with your GPU is a lot more complex and a lot more advanced,
okay.
and how you design the chip is very different as well.
With wider bit paths and the whole thing.
Your memory controller is either geared for one or the other,
okay.
So you have to build it into the design.
So this isn't a situation like they can bin out these expensive AI chips and make the ones that failed cert.
No.
Consumer chips.
No, there are actually different, even though the GPU architecture may be similar inside, the memory and the subsystem architecture can be very different.
The way it connects out to the rest of the computer.
Yeah. Also, the capacity needed for machine learning, we're talking about 128 gigabytes of memory, moving to 256 gigabytes of memory, whereas on a consumer card you may only have 12, 16, 20, 24.
Okay.
But the problem lies in that supply chain, because you've got to put all the parts together. So you need to make sure that your memory provider has enough memory for you. You have to make sure that your packaging provider can put all the chips together with your special advanced packaging, and there's a cost for that. So what companies like NVIDIA and AMD are doing is they're making as many of those as they can. As many as they can be ordered.
If I could sell something for 60 grand, I would make as many of them as I can too.
Yeah. But there is a limit to how many you can make, because there is a limit in the supply chain.
And so is it figuring out which is the smallest supply chain, the shallowest pool?
Yeah, essentially. So that's a combination of how much high bandwidth memory can you get, and you also need it to be at the right speed. How many gigabits per second of speed of memory and capacity. And then the packaging together. Now, both companies use TSMC packaging. It's an advanced technology packaging called CoWoS, chip on wafer on substrate. And the design between previous generation NVIDIA and current is a difference between whether you're using a silicon interposer or organic interposer, and I could speak about that for hours. But TSMC has a limit on how many they can package in a given month or year.
What's that limit?
Is
this a secret?
They won't officially say, but what they have said is that for the last 2 years, they've increased the amount they can do by 60%.
Okay.
And the plan going forward, especially as these technologies get more advanced, is to do more. So when you run out of that, but you still have, say, silicon capacity left in the fab, what do you do with it? You still want to build the most expensive products you can, But you also, say for example, machine learning demand goes down slightly when you weren't expecting, you don't want to be left with a bunch of cards in a warehouse somewhere because it costs money to store them and it's revenue not realized.
And they're not going to get more expensive sitting in the warehouse.
Yes, yeah, especially when there's no demand or the demand drops. So by that logic path, you can say, well, let's use the rest of the fabs in our next highest profit margin part, which for NVIDIA is the GPUs.
Okay.
On some cases, it may be the embedded and some of the the high-profile embedded stuff, but it will be for GPUs. I've spoken specifically to AMD about this, and it all comes down to enabling the supply chain. And AMD's been vocal in that they've been putting money in place for the last 4 or 5 years to ensure their supply chain is rigid and sufficient for purpose to meet the demand for their machine learning accelerators. Well, and then obviously the rest of their silicon supply that they get from TSMC, just in terms of the chips they can order, goes to everything else. It's the same argument for desktop chips versus enterprise chips. The profit margins on enterprise chips are a lot higher. So why even make consumer chips at all? Part of it is also they want to keep presence in that market, and there's a certain volume if you want to keep market share, and investors like looking at market share. But one thing that strikes me is actually notebook chips, right? As a notebook chip, it's some of the lowest margin parts these companies will ever make. So specifically speaking about AMD and Intel here. So why even bother making them at all? Right, and when I spoke to AMD about this, and they said it's the one place where we can combine all of our expertise into one product: CPU, GPU, AI acceleration, high-speed memory, high-speed PCIe. So it almost becomes a proud engineering point to go and do it. And sell some of them.
So what you're saying is my $1,000 laptop here is basically the Bugatti Veyron of the chip fab business.
Well, no, they make a lot of money on Veyrons.
Okay, fair.
It's they would rather you buy a desktop processor, for example, because they get more margin on it.
Interesting.
But no, NVIDIA, a number of us had predicted, and it used to be the case, that the consumer chip would come out before the enterprise chip.
Okay.
Right? That's how it was historically been. And AI kind of switched the game on us. And now, whether there's a slight architecture difference or not, now they focus on what makes the most money. And right now, in this cycle, mega cycle of Web 3. Internet version 7 or whatever, where they go for the machine learning because that's what makes the most money. If they had infinite capacity, would they just make AI chips? No.
They'd still diversify.
They'll still diversify because you don't put all your eggs in one basket, but they're not beholden to a specific time frame. So one could argue these GPUs could have been out this time last year.
But also at the same time they had to look at a big pile of 4090s sitting there. They were still selling it at higher than the original launch MSRP.
Well, there's another argument here. If you are X amount of years ahead of your competition at the high end, do you really need to keep to a very specific cadence? If you can, because the longer you build a chip, the cheaper it should be to make.
Each chip gets cheaper, right?
Yeah. So why bring out the new expensive thing when the old cheaper thing is still top of the pile?
That's a perfect place to wrap it up, I think. Dr. Ian Ketras, thank you as always for coming by. It's wonderful to chat. You can find Ian at Tech Potato on YouTube or wherever fine chips are sold, I guess. I don't know.
Well, I'm going to be buying a 5090. I don't know about you.
I'll be in the line. In the meantime, you can mash the subscribe button on the channel below, and we will see you next time on PC World. Thanks for watching.